Hello everybody, this is Esther here. Welcome to my channel. Today we're going to be seeing the introduction of grade 9 chapter 15 probability. So we're going to be covering all the concepts of this chapter in this video. So if you have any doubts in this chapter, I hope that this session will help to clear all those doubts. So let's get started. First of all, let us understand what is probability. Now, suppose I have a statement like, it may rain today. Let's say I say this to my friend. So what am I trying to actually say through the sentence? It may or it may not rain today. By looking at the climate, I'm just saying that it may or may not rain today. So here I'm not certain, meaning I'm uncertain here, right? And suppose I say she might not make it to school on time. Here also I am being uncertain, right? Because I'm not sure. She may or may not again be on time for school, right? I'm being uncertain here. So basically these statements, I'm showing a sort of probability phrase here, like a probability feeling here. So I'm saying that probably it might rain today. Probably she would not make it on time to school. So I'm being very uncertain here. And that's the meaning of probability. So probability means it's like something is probable to happen. So it may or may not happen. So probability means uncertainty. In this chapter, we are going to be seeing probability in an experimental approach through a numerical value. Okay, so we are going to be seeing how we can calculate the probability of an event. This is a very easy chapter in simple words, and I'm sure you all can score full marks in this. Somewhere here and there you have to just concentrate and focus a little bit, and you will be able to crack it. Some questions are a little bit tricky, but if you practice it many times, it will become easier. Okay, so this chapter is very easy. You can score full marks in this, and very simple and a short chapter. Only one exercise is there. So let's continue with the chapter. I hope you understood what's the meaning of probability, right? Now probability is usually calculated through an experiment, okay, or an action or an operation. So now you know that an experiment is an action or an operation. Now usually in an experiment we perform something called as a trial. Now we define trial as the experiment repeated number of times. Sounds confusing, right? I'll sort it out for you, no problem. Now for example, one second, let's just change the ink. Okay, now for example, I toss a coin, and let's say I toss this coin for 2 times, or yeah, let's just keep it for 2 times. Now in these 2 times when I toss a coin, I can either get tail and head, or I can get head and tail, or I can get tail and tail, I can get head and head, right? So these are the possibilities or the possible outcomes. How did I find this out? So when I toss a coin, first of all, we can get head or tail if we toss a coin once, right? Now if you're going to toss it 2 times, I have to further divide this, right? Head and tail and head and tail. Okay, so I can get head, can get head, tail, I can get tail, head, or I can get tail, tail. Okay, so from this, what can I say? That a trial is an action which results in one or several outcomes. So, in other words, each toss of a coin can be called as a trial. Each toss of a coin can be called as a trial. So, if I have to say, if you get a question like, what is the trial if of a coin if it is tossed once? So, then you can say the trial of a coin is head and tail. Okay. So basically the set of possible outcomes or possible results that can come is called as the trial. I hope trial is clear for you, right? Now moving on to event. Now event is also kind of similar to trial, because an event for an experiment is the collection of some outcomes. Is the collection of some outcomes of the experiment. Okay. So basically in the previous example, if you see here, these are all the possible events that can take place if I toss a coin 2 times, right? So all the possible outcomes of this experiment is mentioned here, right? So these are the events that can take place in the experiment. Okay. Now moving on to probability. You understood what is probability, which means uncertainty. But if I see probability through an experimental approach, I can say that we derive or we get the formula as probability of an event E is equal to number of trials in which E has happened by the total number of trials. This formula will remain constant whenever you have to find the probability of a particular event. Now let us just understand this through a example. Okay. Now for example, find the probability of getting 2 on a dice if it is tossed once. If I get a question like this. Okay. Now you know what is a dice. It has 1, 2, 3, 4, 5, 6 faces, and each face has like first 1 dot, then you'll have like 2 dots, then you'll have 3 dots, then you'll have 4 dots, then you'll have 5 dots, then you'll have 6 dots, right? You'll have 6 dots. These are the on each of the faces you will find all these things, right? Now they're asking me what is the probability of getting this 2 on the dice if the dice is tossed once. Now you know the numbers are 1, 2, 3, 4, 5, 6. If I toss this dice once, what is the probability of getting each of these number? Either I can get, see these are the numbers, 1 minute, numbers, and let's say the chance for this. For getting 1, what is the chance? You have 1, right? 1. And then for getting the number 2 also you have 1. Getting the number 3 also you have 1 chance. 4 you have 1 chance. 5 you have 1 chance. And 6 you have 1 chance. So from this, can you tell me what is the total number of chances? Total number of trials or total number of chances will be 1 plus 1 plus 1 plus 1 plus 1, which is 6, right? Now from this, if I have to find the probability of getting 2, how will I do that? I will use this formula here. So probability of getting number 2 will be equal to the number of times, the number of trials in which 2 has occurred, in which 2 has happened. That is 1 here, right? 1. So it will be 1 by the total number of chances, which is 6. Right? So therefore the probability of getting number 2 is equal to 1 by 6. Understood how we got this? Basically you have to just put a number of trials through which we get the number 2 by the total number of trials, that is 6, or the total number of chances, which is number 6. I hope you understood it. Clear? Now if I have to get the sum of all the probabilities, what do you think will be the final number if I add all the chances, right? Or if I add all the chances of getting whatever my trials and numbers are, if I just add all of that, what is the possible number which will come at the end? Shall we find out? Let's find out. So probability, let's say this, I'm just adding the sum of all probabilities. So if you see, let's take this dice example itself. So for number 1, if you say what is the probability, 1 by 6, same formula we're using what we use for 2. For 2 it is again 1 by 6. For 3 it is 1 by 6 plus 4, for 4 it is 1 by 6, 5 1 by 6, 6 1 by 6. Now when I add all of this up, what will I get? I will get 6 by 6, 6 and 6 nullified, you will get 1. Okay, so what is the final answer you're getting? Therefore we can say that sum of all probabilities will give us 1. You take any experiment, any case, and you add all the probabilities of all the events, it will be equal to 1. It has to be equal to 1. Sum of all the probabilities is 1, and sum of an event, the probability of an event always lies between 0 and 1. The probability of an event lies between 0 and 1. And 0 and 1 is inclusive, meaning it can be 0 and it can be 1 also. But how can the probability of an event be 0? For example, if there is an impossible event, like when I toss a dice, if you have a question like, if you toss a dice, what is the probability? P stands for probability, okay? What is the probability of getting number 7 if you get such a question? Usually what children do is, you know what they do? They add the probability of 1 plus probability of 6, and by the total number of chances they will just add it like that. So because 6 plus 1 is 7, no, so you'll get the probability of 7. That is not correct, man. That is not the right ideology. 7 stands for itself, meaning you have to find the probability of getting the number 7. Okay, like how you will find the probability of getting number 2 if a die is tossed. Similarly for 7 also you have to find the probability. So if such a question comes, what will your answer be? If you toss it dice, you know that the possible outcomes are 1, 2, 3, 4, 5 and 6, right? 5 and 6, you know that this is what happens. But is there a number 7? I'm asking, is there a number 7? Absolutely not. There is no number 7 in this. So what will be the probability of getting number 7? Probability of getting number 7 will be 0, right? If there is no, there is no chance for it coming, then obviously it will be 0. 0 by the total number of trials is what? 6, right? So this is 0. Got it? So probability of an event lies between 0 and 1 inclusive. I hope you understood where we can get 0. For an impossible event, we get the probability as 0. This is an impossible event. Clear? Now let's learn what is sample space. Have you heard of this sample space? I don't think so, because even when I learned this chapter I never heard of it. So now I hope even you guys will understand. Now what is sample space? Sample space is defined as the set of all possible outcomes. this is sample space. Clear? This is the sample space, set of all the possible outcomes. So let's say, for example, if a coin is tossed thrice, write the sample space. You can get a question like this. In some of the reference books also such questions are there. Okay, write the sample space like this. You can get, not only for coin, you can even get for dice also. Other things are also there, but for starters I'm just showing you, if a coin is tossed thrice, what will be the sample space of it. Okay, now you know that if a coin is tossed once, you will get head or tail. If a coin is tossed twice, you will get head head, head tail, or tail head, or tail tail, right? But if it is tossed 3 times, what will you do? So basically you will further divide this head tail, head tail, head tail, head tail. I'm telling you, this is the simplest way of calculating the sample space. If you use this method, this division method, you can easily calculate the sample space. Don't need to break your head also, right? So the more the number of times the coin is tossed, the more the number of times you will keep on dividing this head and tail, head and tail, head and tail. Okay, you will go on dividing depending upon the number of times it is tossed. If it is 2 times, means you don't even need to do this division. Only head and tail will be divided into head, tail, head, tail. That's all. Okay, so I hope you understood it. Clear? Now coming to how do we write the sample space. Now we finished dividing it. Now all we need to do is just group it. Now you will get head, head, head first. So head, 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 then head, head, tail, head, head, tail, then head, tail, head, head, tail, head, head, tail, tail, then you will get tail, head, tail, then tail, head, first you will get tail, head, head, then tail, head, tail, then tail, tail, head, then tail, tail, tail. So now this is the sample space if a coin is tossed 3 times. Clear how we did it? So I hope you understood what is the meaning of sample space. Basically the set of all the possible outcomes. See, this trial, event, sample space, all these are kind of interconnected in some way or the other. Okay, now just few more things and we will be concluding this session. Okay, as I told you before, the probability of an impossible event is 0. I told you right here, impossible event, probability of impossible event is 0. Now always if I add the the possible events plus the impossible events, together the collection of these events are called as complementary events. When I add these two together only, I will get something called as complementary events. Okay, now if I have the probability of occurrence of an event, if an event is suppose occurring, plus the probability of non-occurrence of an event E. Non-occurrence means an event is not happening. So thus I can say that this is probability of an event E which is occurring plus probability of an event E which is not occurring. This will be equal to 1 always, right? So the sum of the possible event and the impossible event will give you 1 is what they're saying in other words, right? So this is what this chapter is all about. So simple, right? All these concepts are so simple. I feel at least that they are so simple and you can score full marks in this, but because at least I scored full marks in this, and I'm sure even you guys can do it. If you have any doubts, please let me know in the comment section down below. That's it for this session. With this we wrap up this session. Thank you so much for watching this video and see you on